Hi there, welcome to the lab. Today we're going to have a look at this Aneng. This is an M109 in red that I got from AliExpress. This is billed as a voice broadcast multimeter. I was really intrigued to find out what that means. We'll be having a look at that. Now, as I mentioned, I got this from AliExpress, and so I'd just like to ask that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated and it helps me figure out where to focus my activity. Now, let's get into the box. What do we have here? Okay, fairly nondescript, but that's all good. The meter itself is very nice, compact, and small. Reminds me of the 303. There are a pair of probes here. We'll have a look in a second. Chinese manual and an English manual. Okay. Now let's have a look at the probes just before we get super started. So these are what I call small size probes and small connectors there. The probe tips are not really very sharp, but that's okay. It is a fairly inexpensive unit. Now the exterior has a molded rubber bumper or overmold, but I don't think, oh no, it does come off. So it will come off. We might have to, we'll do that later. But for now, I just need to get the batteries in here. And that comes out, and the screw goes directly into the plastic, which I'm not really very fond of. I prefer to see a threaded ring in there. Over time, you'll probably end up chewing the plastic body up with the screw. Two AAA batteries. One goes in like that, and one like that.
Already on.
Okay, it talks. Well, that's different. Let's get this back together. Okay, so turned on right away with the batteries on. We can see the display is actually very nice. It seems very crisp. All right, let's turn it on and have a look at the basic functionality on the unit.
Already on.
Okay, so it tells us that it's on. What we see here, just going through the functionality, there's AC and DC voltage, capacitance, continuity, AC and DC current, limited here to 2 amps, resistance, non-contact voltage, diode check, and frequency. And of course, we've got the plugs for that. It's really, I have to say, it's really quite a small unit. And up here, we've got the button to enter non-contact voltage mode. This is used.
DC voltage measurement. AC voltage measurement.
Okay.
Resistance measurement. Diode measurement. Capacitance measurement. Frequency measurement. DC current measurement. AC current measurement.
Okay, auto didn't get announced.
DC voltage measurement.
Okay.
Now contact voltage measurement.
Okay.
Gate lighting.
So that's hold, and then
Lighting on.
there's a illumination here on the display, and there's also a light here. They don't appear to be controlled separately.
Lighting off.
Okay. Well, I wonder if it's going to talk when I do measurements too. But so far, that's just totally different. I've got to tell you, I think this is really cute. I'm not sure how else to put it, but it does announce the mode that we're in, which is pretty cool. You know, as multimeters go. So I'm going to start out here with auto mode, and initially I'm going to put some voltage into the calibrator. The challenge I have with auto mode is that it has to figure out what mode it is and whether it's a voltage or a resistance. And when the voltage is low or the resistance is low, the system gets a little confused by that. And so let's plug this in. Okay, so right now you can see it's thinking that it's in a resistance mode, so the buzzer's going off and it's not showing 0 voltage. And if we bring that up to 1/10 of a volt,
Distance measurement 0.6113 thousand ohm.
so you can see it thinks it's in resistance mode and not voltage. So it's not really reading the small voltage here. Let's go up.
Resistance measurement 1.507 thousand ohm. Resistance measurement 2.905 thousand ohm.
Okay.
Resistance measurement 19.33 thousand ohm. Resistance measurement 8.62 million ohm.
Okay, there at 1 volt.
Voltage measurement 1 volt.
So now at 1 volt, it's recognizing that as a voltage measurement, finally, and not as a resistance measurement. So that's good to see. But like I say, that's one of the challenges with auto. Now what I'm going to do is I'm going to switch over to resistance. So now the calibrator is in resistance mode. It's set for 20 ohms. And now it is picking it up as ohms, and it's a very accurate reading, actually. You can see 20 ohms. And the buzzer sounds because usually that sort of indicates a continuity situation below about 50 ohms. Let's bring that up. So
Resistance measurement 59.7 ohm.
okay, so you can see that you have to kind of exceed that continuity threshold for it to stop the buzzer and for it to convert that into a resistance measurement. So below 50 or 60 ohms, it wants to think of that as continuity, and it's not going to, I mean, it does show the resistance, but it also has the continuity buzzer running. And so that's one of the challenges that I face with auto mode, is that it will work for higher resistances and higher voltages, but for lower resistances and for lower voltages, you'll need to use the dedicated modes anyways. So why not just use them all the time? That's my view. And so you can tell I'm not generally a huge fan of auto mode. Now we'll have a look at DC voltage proper. And of course, because this talks to me so much, I wanted to wait.
DC voltage measurement.
So it's set up to measure DC voltage, and I'm going to connect it now. And 0, perfect. Interesting that it's not actually telling me it's a 0 measurement, so it's not talking to me quite yet.
DC voltage measurement 0.099 volt.
Okay, so now you can hear the reading there, and it's off by I don't know, maybe 1/1000th of a volt here, so not a big deal. Let's go up to 1 volt.
Voltage measurement 3.002 volt.
Okay, well, it told me the first measurement, and it's not telling me the measurement now. I wonder if there's a way to get that to broadcast again. Let's go up to 5 volts.
DC voltage measurement 5 volt.
That's a good reading. That's nice. Let's go down here a little bit to 4 volts.
DC voltage measurement 4 volt.
Okay, that's good. Let's try 2 volts.
DC voltage measurement volt.
Okay. And then let's go up to 10 volts.
DC voltage measurement 9 volt.
Okay, well that's 10 volts now, and so that's accurate. And so we're seeing from what I can tell, although I'm kind of distracted by the fact that it's talking to me all the time, it seems to be fairly accurate in terms of the voltage. I'm going to have to go through some of these other modes a little more quickly. The voice broadcast, although it's I guess different, it's kind of slowing me down here in the process. For AC voltage measurement, I've got the Bryman as a reference point. Now, both are currently in AC voltage measurement mode. You can see a little bit of ghost voltage. The power's not on. I'm going to turn the power on.
AC voltage measurement 121.2 volt.
And you can see that there is a difference of about 0.2 of a volt between the Aneng and the Bryman. Now looking at DC amps or DC current, the calibrator is going to output some milliamps here. And so right now it's 0. We're seeing 0, which is a good thing. There's 1 milliamp. Almost a milliamp there. 2 milliamps. Almost 2 milliamps there. Oh, now we're at 2 milliamps, which is good. 4 milliamps. Almost 4 milliamps. 8 milliamps. That's good. 12. Okay, just a tenth there. 16. Once again, off by a tenth. 20. Just off by a tenth. And then finally 24. So reasonably good in the DC current space, generally just off by a tenth in the last digit. Now for AC current, I've got the Bryman set up in current, I've got the Aneng set up in current, I have an AC fan that I use as a load. Power is currently off. Let's turn the power on. There's initially a high current as the fan comes up to speed, and then once the fan settles in,
AC current measurement 167.2 milliampere.
okay, so the Aneng announced the value. You can see that there's about a 0.4 of a milliamp or a 400 microamp difference generally between the two meters. Now I'm going to have a look at resistance.
AC voltage measurement, diode measurement, DC current measurement, AC voltage measurement, resistance measurement.
Okay, we're in resistance measurement. Now I'm going to connect it. Oh. Okay, well I don't like that in the dedicated resistance mode. It is accurate, but the buzzer is sounding. A little bit of inaccuracy there. And then
Resistance measurement 59.7 ohm.
so that wasn't auto mode, but the buzzer was still sounding. So I'm not too thrilled with that behavior. And we're off by 0.3 of an ohm here. Let's go up to 100.
Resistance measurement 99.5 ohm.
Yeah, 99.5, 0.4. Let's go up to 500 ohms.
Resistance measurement 0.496 thousand ohm.
Yeah, so it's off by 3 or 4 ohms there. Let's go up to 1K.
Resistance measurement 0.994 thousand ohm.
Yeah, so it's off by about 6 to 7 ohms there. And let's go up to 2K.
Resistance measurement 1.988 thousand ohm.
Yeah, so in this case, it's now off by 12 ohms overall, and then that's where it maxes out.
Measurement 2.187 thousand ohm.
So the calibrator maxes out here at 2200 ohms, and there's a discrepancy you can see there of 13 ohms on the reading. Now for diode mode, I have a test box. Let's get the probes in here.
Diode measurement 0.232 volt.
So that's a good reading for the diode there.
Range.
That's a good reading for the diode there.
Range.
That diode lights up.
Range.
That diode lights up.
Range.
That diode lights up. That lights up, and that lights out.
Measurement 2.639 volt.
So
Range.
all the diodes light, and
Range.
good measurements on the diode. No tone or no short tone on the sort of valid diodes. Now for capacitance mode, I've got a reference board. The calibrated values are up in the overlay.
Capacitance measurement.
Meters in capacitance mode. Let's start measuring. I'll call them out. This first one is 100 picofarads.
Capacitance measurement.
Not too bad.
0.09790 farad.
But the value keeps dropping.
Capacitance measurement 0.
Now this is 1 nanofarad.
290 farad. Capacitance.
So the 1 nanofarad measurement seems okay-ish. This is 10 nanofarads.
Capacitance measurement 9.91.
Little, that's dropping down.
Capacitance measurement 99991.
This is 100 nanofarads.
Capacitance measurement 99.790 farad.
This is 1,000 nanofarads.
Capacitance measurement.
So that's a little low. And then this is 10 microfarads. So that's a pretty good measurement for the 10 microfarad capacitor. For continuity, continuity can either be done in the auto mode or in resistance mode. I'm doing it in resistance mode now because the performance in auto mode for continuity is generally not very good on any meter because of all the things it tries to figure out. But let's see what happens here with the standard tapping test. So we can see
range.
So you need a pretty solid contact. Just basic taps. Sometimes the display catches it, sometimes it doesn't. And if you get a solid contact, it will trigger the buzzer. But it's pretty slow for continuity. It's probably one of the slowest meters I've seen when it comes to continuity in that regard. Now looking at frequency.
Diode measurement, capacitance measurement, frequency measurement.
We're now set up here to measure frequency, and well, nothing's connected really at this point. The calibrator is putting out a 100 hertz signal. It's showing it as 0.1 kilohertz just because of how it works. Now if we connect this, it's not showing anything, which is fairly typical, believe it or not, because the calibrator is putting out a square wave, and a lot of meters won't pick up the square wave. They'll only react to a sine wave, and so I'll switch over to a sine wave for a second. So now I'm going to connect the AC power, which I'm using to generate a sine wave.
Frequency measurement 60.05 Hertz.
And so we can see that it is picking up the sine wave and it's measuring it, although it seems to be off by a few
0.08
hundredths
hertz.
of a hertz, about 5 hundredths of a hertz, because the power line signal here is pretty dead on to 60 hertz. Now for non-contact voltage, I take the plug here. This is where the hot line is, and the non-contact voltage sensor is right there. And so we'll bring that into proximity and we'll see what happens.
Now, contact voltage measurement.
Oh, so it's responding very far out. That's great. Yeah. So that's very good performance of this non-contact voltage sensor, especially given that it's starting to see the non-contact voltage here almost 2 centimeters away from the sensor. That's really strong performance for the non-contact voltage sensor. I mean, by the time we're 1 centimeter away, it's already 2 or 3 bars. Very nice. I like that performance very much. Now, quick teardown. We remove the rubber overmold, and there's 4 screws here. And then this comes apart. Now, there are quite a few wires here. The battery compartment is wired in, and this speaker that's used for the voice presentation is wired in, so it doesn't just come apart easily or without, let's say, wires. The core control chip is obscured. Now we can see here the light, the LED for the light, the non-contact voltage sensor is there. There's a PTC here. I don't see at first glance any fuse. This is labeled as a 15C V2, and so that means I might need to figure out who the OEM is, because the manual also talks about 15C, and of course this is branded as an M109 or labeled as an M109. This I think is the buzzer that's used, so for things like continuity and non-contact voltage, it uses that buzzer. It's not going to use that main speaker. There's a relay here, and that relay is used in meters that have soft switching. You tend to see that a lot because there's no mechanical switch in order to shift the inputs to different lines on the DMM control chip. And this is probably, given that there's only one sort of, well, maybe this is, I'll have to look with the magnifying glass there. This is probably an EEPROM with some flash memory, with some configuration and calibration information. The voices, or the voice, is probably on this main controller chip. It's probably an application-specific one for this meter. And it also does the LCD driver, and the multimeter functional sensing is done through there as well. But as is typical with the high levels of sort of integration here, not a lot else to see on this unit. Everything is really integrated into this one chip. The voice might be on the EEPROM here, or it might be in the ASIC that controls the unit overall. This is a very small, compact, and inexpensive meter meant to cover all the basic electrical properties along with an innovative voice output. The unit has a very crisp display that is a pleasure to look at. The voice broadcast definitely hits as a cool feature, one that I have not seen in any other multimeter.
Lighting on.
It might be handy for someone with vision impairment or in a situation where it's not possible to look at the display. The non-contact voltage performance was excellent. Accuracy overall is reasonable outside of capacitance. On the other hand, the voice feature was annoying at times.
Lighting off.
Listening to the voice is slower than reading it directly from the display, and there is no way to turn the voice off or trigger it manually. When the measured value changed after the voice readout started, the voice readout was of a stale measurement, and there was no follow-up update with the stabilized value. Continuity was very slow, and I was unable to get my standard gold-plated probes to work with this meter. The frequency measurement was unable to pick up the square wave signal produced by the calibrator. The battery compartment on the back is held in place with a screw that goes directly into the plastic body. This will erode the plastic after a few battery changes. There's no fuse on the current input line, and thus current measurement is limited to 2 amps. I got this meter because of the cool voice feature, but in the final analysis it was more annoying than useful. If you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Thanks for watching, and until next time.